Who was it that said, if you understand quantum physics, you don't really understand quantum physics? Consciousness, intelligence, free will, determinism, black holes, protecting the planet from asteroids, Heisenberg's uncertainty principle, atoms, ion traps, nuclear magnetic resonance, superconductors, photons, artificial intelligence, machine learning, past and future, classical physics, time travel. I mean the whole thing.
Quantum physics puts everything into question. It defies every intuition you have about the real world. It is a very strange regime of physics. Things can exist in a state of superposition, where they could be like ghosting each other. They could be this or that at the same time, known as quantum entanglement. Quantum entanglement: if two objects are quantum mechanically entangled, then they are strongly related to each other even after they are vast distances apart. The notion of multiverse, there could be families of creatures in different states going through different experiences and having different life trajectories. The most famous one is called quantum tunneling.
For a long time, people thought those effects only existed in the microscopic domain, like atoms, electrons, photons. But it's really the theory of our universe. So, if you want to build a quantum computer, you want to incorporate those new phenomena into information processing.
Maybe quantum computation is one of those instruments that's going to allow us to see quantum effects at the human scale. Google and NASA have teamed up to share one of the world's first commercial quantum computers. This machine, made by Canada's D-Wave, will be installed in a NASA research center in California. This is the inside of one of our dilution refrigerators. All of this infrastructure is to basically operate the chip at a temperature that's 2 orders of magnitude colder than an interstellar space. The processor is a quantum computer, but uses things called qubits, as well as being either 1 or a 0. A qubit can also be both at the same time, therefore bringing about a quantum leap in terms of power.
If we can solve optimization problems better, we have a very important resource in our hand.
Overwhelmingly obvious killer application for quantum computation is optimization. Optimization problems are really difficult to solve. Even if all the Google servers come together, they are not capable of coming up with the best solution, as these optimization problems get larger.
Let's give you an example. You want to do a trip through South America and you want to visit a number of cities, and then you ask, what is the cheapest ticket I can get to visit? Let's say 20 cities. And you can. Imagine I list off all the different options of routes and airlines that I can use to travel to these cities.
Currently, as a civilization, we generate vast amount of data. It can be climate data or genomic data, but it is very difficult to generate useful insight from that data.
We think it teaches us that we shouldn't be naive about our world and wonder what the reality around us is actually shaped.
I can't ask how long I will live or the meaning of life. Really, we don't know what the best questions are to ask to the computer. But that's what exactly we are trying to understand. Now, to me, the most important question is, are we alone?
This is, of course, a long-term question, and there are still tremendous obstacles and big questions. Some of these will be resolved by D-Wave, some of these will be addressed by Microsoft, and some will be addressed by Google.
How amazing it is that we, with our monkey heritage, monkey brains and monkey fingers, have somehow lugged our brain to ask legitimate questions about the nature and physical reality.
I thought we wouldn't be able to experiment with quantum computational devices in our lifetime, but now I'm confident that we will be able to. It's that human race to go forth into the unknown frontier, whether it's space exploration or quantum exploration. We do it because it must. We do it because that's what it means to be human.